Everybody settle down. Please do keep your phones in your pockets. Okay, if any of your friends is left or still not present in the auditorium, please do call them. Welcome back everyone. I hope you had a good chai break and a few interesting conversations. Everyone here would agree that serverless apps are like Indian Jugaad. In English, what we say, flexible, efficient and surprisingly powerful when done right.
It's now time for our second session where we'll explore one of the most in-demand skills in cloud computing, building resilient serverless applications on AWS. Leading this session is Mr. Nishan Buddhi, a seasoned cloud expert and community contributor who's passionate about simplifying serverless and architecture for developers of all levels. And remember, again, there will be a quiz question at the end of the session too. Make sure you're attentive and you might walk away with some goodies. So, please join me in welcoming Mr. Nishan Buddhi sir with a big round of applause.
Thanks a lot. So good evening everyone. I hope सबकी चाय हो गई है, थोड़े fresh हो गए वापस, right? So before we begin, I just want to, like, with a raise of hands, how many of you have tried to buy something during like from Amazon? I'm from Amazon, so from Amazon or Flipkart or something, and at the last minute the payment failed. How many of you have done that, experienced that? And how many of you have done that during a Diwali sale or a Big Billion sale? A lot of people, right? So keep your hands up, just for a scope. Yeah, for the previous question, whoever has experienced that. Yeah, so you can multiply this number by at least 10 million. That is the number of dollars that a company loses each time a customer like you is facing a difficulty while checking out a product or something like that. And as soon as you are facing an issue, so Flipkart में problem हो रही है, what will you do? You will go to Amazon and check for the same thing, right? So basically Flipkart lost that money, we gain that money. So that is what we are here to understand, how to avoid that thing. I'm Nishant Buddhi, and I'm also a technical account manager at AWS. And a brief about myself is that I'm from Nagpur as well. I've been in Nagpur since I was born, and I've done my schooling from St. Point School, Nagpur Road. And to give us like an idea of how long I've been in Nagpur, is that I've seen Futala when there was just a road there, nothing else. Then I've seen the Domino's come in, then I've seen a lot of shops come in, then I've seen the fountain come in and also not work at all till now. So, yeah. But now I'm based out of Bangalore. So let's begin. Yeah, everything's working fine. So let's begin with reliability. The definition is given there. A reliable workload performs its intended function correctly and consistently when it's expected to. Each of the parts of the definition is as important as the others. If a workload is performing correctly and consistently, but not when you expect it to, it's not a reliable system, right? So that's So that is what reliability is. But reliability is an outcome. You need to ask questions like, to be reliant, you need to know what is causing the errors and how do you come back from it? How do you resolve those? How do you handle those? Yeah. So, has anyone heard of Werner Vogels before? Oh, nice. Before joining Amazon, even I hadn't heard it. So he's the CEO of Amazon.com, and he has a very famous quote that we use extensively in summits, in customer meetings, everywhere. Everything fails all the time. So this is not something that we are saying just to like shrug off responsibility for what happened last week in the IED failure, right? So this is something, because everything fails all the time, I'm saying that because the next week even Microsoft failed. So it's not something that we are saying just to shrug off responsibility. So how many of you have seen like experienced scenario when you are about to give a presentation and your internet fails? Yeah, quite a lot of you, right? So it happens from the smallest things to the largest of scales. So that's why everything fails all the time. But rather than how do we prevent failure? So since everything fails all the time, you can't prevent failure, right? So how do you handle failures is what we are going to look at. Okay, so serverless. There's a big misconception that people think that serverless means there's no server at all. Because I was, like, last night I was talking to my dad and I told him that I'm giving a talk on resilient architectures in serverless. He's like, serverless doesn't have servers. No, it doesn't mean that. If you look at the definition, it means a workload that runs code and scales automatically without developers managing the servers. So all the heavy lifting goes on to the AWS infrastructure on the AWS end, and you just have to focus on building your application, how to make it better, rather than worrying about how much to deploy, what to deploy, and all that. So let's go through a story of sorts. When I was a kid, like early 2000s. So I used to go to my dad's office, and there's a server in their floor. And if anything goes wrong with this particular server, there's a monolithic architecture, it's just one server running in a server room. And if anything happens to it, your entire application is down. Like when I am pretty sure people even face that situation when they go to SBI and they say server down and kuch nahi ho sakta. So that is what used to happen earlier. Then came cloud, came AWS, other providers. What happened is that for resilient architectures, we used to build with, say, if you even look at this architecture, there are two instances in two different availability zones. There's an auto scaling group which will scale according to your demand. And there is, even your database, you have redundant information there. So redundancy as in not useless, but it is there just in case the primary fails, you have a standby. And you have the entire network configuration as well. So when I was telling you about this architecture, does it feel a bit complex? Yes, no? Seems easy? Nice. Because when you scale it to the workload of, say, an Amazon or Netflix or, say, Spotify, their architecture involves like thousands of instances, thousands of auto-scaling groups, and terabytes and zettabytes of data. So this is what is called a traditional approach in a cloud environment. Then people started building with serverless technologies like Lambda. So to make serverless more clear, how many people for this event came via their own vehicle? Say, it can be two-wheeler, four-wheeler, any of those. How many of you took a cab or an auto? Even distribution. So I would say that if you took a cab or an auto, you took a serverless method of transporting yourself here. So, and the people who came by their own cars, they went by the traditional method of transporting themselves. So the thing with serverless is that, I'll take the same example. So if you wanted to come, say, to Persistent from wherever you're coming from, Jeripatka, Jazil. So when you're coming there and say your vehicle breaks down, if you have your own vehicle, then you need to fix the vehicle, you need to check what's wrong, how can you resolve it, how do I reach there? That is all your headache. But if you take an Uber, Ola, Rapido, anything, if you book an Uber, a cab is coming, the cab breaks down, it's Uber's responsibility to send you another cab, right? So that is what happens with serverless as well. So it's AWS's responsibility that you have compute power, not that you have to configure your instance, and if your instance goes down, you bring up a new instance. That is not your responsibility. So I was talking about responsibility, right? So building resilient and reliable architectures is a partnership, I'd say. Knowing exactly who's responsible for what helps you in times of crisis as to avoid any kind of finger pointing. No, it's yours, it's mine, we don't know. Shouldn't happen that. So let's do a small activity. Let's say the section is AWS, and the section on the right and left are customers. So whenever I mention a particular responsibility, the side that is responsible should raise their hands. Okay, ready? Chai pee? Okay, so hardware failures and replacement. AWS, that's correct. Your application code having bugs. Yeah, that's the customer's responsibility. Itna bhi responsibility nahi. Then network connectivity between AWS regions. Straightforward. Then configuring your database access patterns. That's the customer's responsibility. Setting up proper error handling mechanisms. Customer's responsibility again. सब कुछ AWS में डाल रहे हो. So you see a pattern emerging, right? So AWS handles the infrastructure, and the customer needs to handle the how of it. Like, how do I manage it? How do I resolve the errors? How do I scale it further? All those things generally comes under the responsibility of the customer. So there is a well-architected framework that AWS is famous for, which has 7 different pillars. We'll just be looking at the reliability pillar today. So it has these 5 points, I'd say. Automatically recover from failure, test recovery patterns, procedures, scale horizontally to increase aggregate workload, stop guessing at capacity, and manage change in automation. So for today, we'll be focusing mainly on these 3 reliability design principles. So automatically recover from failure, I'll give you an example. If, say, you have an active data plan and you're connected with the Wi-Fi currently, and you're opening up a website, and in between you turn off the Wi-Fi. So your phone does not ask you, should I go to data and then load the particular website, right? It will automatically switch to data and load the website further. And scaling horizontally to increase aggregate workload. A lot of words, but so imagine if right now there's a fire and everyone needs to get out of the auditorium. Would building a big door help, or having 2 different, 3 different, or 4 different exits be more convenient for dispersion? Yeah. So rather than scaling up one particular instance, you can put up 4 different, or however many you want, horizontally, so that they can share the load. Yeah, the main topic of the day. The ability of your workload to withstand partial and intermittent failures across components. So we have established that everything is going to fail some or the other time, right? So being resilient means even if it fails, I can handle the failure, I can come back from it without causing a lot of business or revenue loss. So let's check what all can go wrong. In Amazon EC2, which are the basic instances that you use for your servers, there can be a loss of network connectivity, loss of power. There can even be an issue where the warehouse the AC might have gone, air conditioning has malfunctioned in the warehouse and everything's heating up. Even that can happen. The underlying software patches, those can fail. And within the particular instance that you're using, the virtual machine that you're using, there can be RAM that has been exhausted, the file server system that it's using, that can get corrupted. So we tried to So we tried to solve resilience by making use of autoscaling. But again, autoscaling can be a bit tedious. It solves the problem 99% of times. But again, there is a lot of complexity that is involved with it. Which metric to use for scaling? Do you look at only CPU utilization? CPU is working fine, but the requests that your application is sending, they are slow. So you need to check which metric to be used for scaling. So again, like fleet metric, business metric, time based. Then health checks. What defines whether your system is healthy or not? And all these things require a lot of overhead, they require a lot of planning, and it needs to scale on time as well. Because if there is a need for more servers, so currently there are 2 servers. If there is a need for 4 servers, the time that if you do not scale up in time, then the time that is taken to, say, bring up the other 2 servers for that particular 3 or 5 minutes, if you have very big architecture, then thousands of requests can just go waste, right? So that is something that we need to avoid. So with serverless, multi-easy comes for free. This, if you look at this diagram, it seems much simpler than the last one, right? That is because AWS, it's not because I have removed all the complex items just so that you can see a nice diagram. AWS is handling all that in the backend for you. With serverless, the major advantage is that high availability and fault tolerance is built in. You do not need to configure it separately. It will scale, it will check if a Lambda instance is working or not, if there are enough Lambda instances for you, and manage the failure to an extent, yes. But even while using serverless, how many of you have run a Lambda function? Quite a bit of it, right? And have you seen this error message before? Not a lot of it. Nice? Quite resilient. So when this happens, so this is bound to happen sometime. Like even Lambda might face some internal issues. But the question is, how do we handle errors more gracefully and recover quickly? So see, when you are running a code on Lambda, that's you seeing this error message. But when you deploy your application and an end user is seeing this message, they don't care that it's a Diwali sale time or a new show has been released on Netflix. If you see that, Netflix is down or Netflix is not working properly, you don't care that Netflix is facing high traffic, you just want to see a show, right? So that is what happens. So the end user does not care that you are facing an internal issue or something like that. They just want their task completed. So to understand that, let's look at the event source integrations that Lambda has. Synchronous, asynchronous, and pole-based. Synchronous is like a phone call. When you call someone, so you expect them to answer at that point, right? Either you answer or you don't. So you call your friend. If they're not picking up, you get a message that they're currently busy or cannot answer. Asynchronous is like sending a parcel from, say, Blue Dart or somewhere. You go to Blue Dart, you give your parcel to them and tell them that please send it to, like it's a birthday gift, send it to my friend who stays probably in Bangalore. So when you do an asynchronous request or when you're giving the parcel to Blue Dart, you expect them to, once you're given the message, you expect them to do whatever comes next. You expect them to handle the delivery. You even expect them to retry it if your friend is not at home. So similarly, in an asynchronous request, retries are also a part of it. And finally, there is pole-based integration. So suppose you are given an interview for a company, say Persistent, and your interview went well, and you're looking for some good news on your email. So will you sit in front of your, say you're using Gmail, will you open Gmail and sit in front of it the entire day? No, right? First you'll check it for 2 hours, then you'll check it every 4 hours, then you'll check it next day, then you'll finally give up hope and nail it. So that is what pole-based integration is. And each integration, the errors or the retries are handled accordingly. We'll take a look. So with synchronous invocations, you have just one attempt to succeed. You either succeed or you fail. There are no automatic retries automatically in AWS. But it depends on what kind of error it is. So who can tell me what is the difference between a 4xx and a 5xx error? Anyone, just shout out.
4xx is client side, 5xx is internal server side.
Yeah, 4xx is client side and 5xx is server side. So what does client side include? Maybe you have sent an incorrect request, or there are certain parameters that you missed, something like that. And server errors could be like your database is overloaded. But in this particular scenario, which one do you think should be retried? Any raise of hands? Client and server, which one should be retried? Server side, okay. So if, say, a client is sending a request, say, I'll give you an example of McDonald's, okay? You're giving an order of, say, a Maharaja Mac, and the guy did not hear you properly. The cashier did not hear you properly. So, should he say that, can you repeat, I didn't get your order properly? Or should he just create 3, say, McCrispy, Maharaja Mac, and another burger, assuming that 8 to sahi ho gaye? He won't do that, right? So, that is exactly what we do. So, in a client request, if their request is incorrect, then there's no point of retrying it, because each time you're going to get an incorrect request. So whereas if a database or something is overloaded, retrying makes sense because maybe currently the database is overloaded, but after 2 seconds, 10 seconds, the workload might have reduced and the request might succeed, right? So now do you know which kind of request we should usually retry? Yes? Awesome. Okay, so don't waste work. What does that mean? So this particular principle will save you a lot of money and effort. So a user clicks a button in your application and they wait for 30 seconds and still they have not received the particular response that they wanted. And they'll shut it down, right? They won't sit around forever. So after they have shut down or they have, say, changed the page or changed the app, it doesn't make sense that the server is still processing the request and eventually give the response when no one is waiting for the response. Similarly, if an API gateway is integrated with a Lambda function, so the API gateway has a maximum timeout value of 30 seconds. And if your Lambda function is having a maximum timeout value of 45 seconds, it doesn't make sense because say there is a particular request that is taking even 35 seconds. API gateway is going to say that timeout and not be able to give the response. In this particular scenario, you should keep the Lambda's timeout value as 25 seconds so that even if Lambda is not able to, say, complete the processing, it can send an error message in time that this request is too big, I can't process, or something like that, rather than just sending a random generic timeout each time. So timeouts are your friend. They will help you reduce the work in a way that you don't have to pay for extra processing and you pay in only for what you use. Asynchronous invocations. So when you drop a letter in your mailbox, you wait. Do you wait for the letter to be picked up? You just drop it, leave it, right? So the mail guy comes, takes the letter, sends it. So an asynchronous request is something like that. So when you invoke a Lambda asynchronously, the request will go to the Lambda queue. That is, again, this part is also handled by AWS. It will go into the queue and wait for its processing. And there are certain configurations that we need to make and be aware of during this time, which would be maximum event age, maximum retry attempts, and destination. So maximum event age is similar to the one that we talked about previously. So if there is a request that has been sitting in your queue for say 30 minutes or something, and you you wanted a response within 2 or 3 minutes, you can simply drop that particular response, right? Request, right? And maximum retry attempts. So the number of times you want to retry that particular message after the initial attempt can be configured. It is either 0, 1, or 2. After that, you can send it to something called a DLQ or a dead data queue that we'll talk about later. So don't work on old messages. That is what I was talking about. So consider you have an intraday trading app where every minute the share prices are changing. If you send in an order to buy say 100 rupees worth of shares, and that request is processing till say even 2 or 3 hours, it doesn't make sense. Because in those 2-3 hours the share price might have dipped, might have increased. So it is better to drop those particular pieces of work or those messages, or you can send it to the dead letter queue. So dead letter queue is not where the messages go to die. Dead letter queue is where you send the messages for some special kind of treatment. Either you will check as to why they have been sent to DLQ, or you can just discard it, or you can check if there is some issue with the request as well. So if you want some special kind of treatment that you want to give to the messages that have been tried again and again, so that is where you send the messages for DLQ. So I'll give you an example. Yeah, if you go to a restaurant, say that closes at 11 p.m. and you go there at 10:55, let's take the example of Haldiram's. You go there at 10:55 and say that you want a sizzler. Sizzler we usually take around 10-15 minutes to cook. So will they take the order and cook it for 5 minutes and say, "नहीं मैं और नहीं बना रहा, इतना ही लेना है लो, वरना जाने दो." They won't say that. It's better to reject that order saying that we cannot fulfill this order. You can try for say a papri chaat or something like that. So that is what I mean when I say don't work on old messages. Then we talk about poll-based invocation. So everyone remembers the email thing, right? That I told you about. So with poll-based invocations, you can send, so Lambda will either poll say an SQS or a Kinesis tree, and it will keep polling for new messages, and it can even take messages in a batch. And if a particular batch fails, it will retry the entire batch. Again, so it depends. There are certain configurations that you need to take care of. It can be maximum record age, maximum retry attempts, or bisect batch on function error. So when you're handling a batch, say of 10 messages, and for the first 9 messages are getting processed fine, but the 10th message is causing an error, so the Lambda will try the entire batch again. So it will keep trying that, and till the time that the particular traffic increases and Lambda cannot process it anymore. Rather than that, when you use the bisect batch on function error method, it will keep bisecting your particular batch, say 10 into 5 two batches of 5 messages each, process it, and keep bisecting it till you find that particular message, and then you can send that message to your DLQ. That one message that in the previous example that was causing the entire batch to be tried again, that is usually called a poison pill. It is something like a food that you are allergic to. If you say you have a peanut allergy, you keep having peanuts, you keep facing that skin problems and all those things. So something like that, we have something called a poison pill. So rather than processing it again and again and increasing the workload on the server, you can send it to the DLQ where you can check how to handle it. With Kinesis, you even have something called a checkpoint. So instead of there's something called splitting your batch recursively, and there's also something called a checkpoint. So Kinesis, when your Lambda is processing messages from Kinesis will keep a checkpoint till which the processing was successful. And next time when the batch is retried, it will remember that till this point the particular invocations were successful, and I have to try processing from the next point. It's something like a game checkpoint that you reach, right? Scale horizontally to increase aggregate workload and availability. So if I kept a big wooden table here and I called 4 of you here to lift the table and say keep it in the backstage, you will be able to do that easily. But if I say that only one person has to do it, that one person might be able to do it, but he'll say have back pain, he won't, he'll have some leg pain or something like that. So we don't want that. Similarly, for an EC2 instance, even if a very highly scaled instance has a lot of workload, it is possible that it may break down under extremely high workload. So instead of that, scale horizontally and create new instances or new workloads that are sent to parallelly scaled instances. So we'll take a look at how to do that, and before that, we'll take a look as to why am I saying that we need to horizontally scale. So servers are optimistic. They keep taking on requests one after the other, one more, till the time they can't take it anymore. Each particular server or a particular instance has finite resources. They will have finite CPU, finite memory, finite storage, finite network bandwidth. So as the overall load increases, you should scale out horizontally. Or else you'll face a lot of retries, and say you have 1,000 requests that are coming in and your server can't handle those requests, so you retry them. So now those 1,000 are there, and on top of that you have 1,000 of the previous retry. So you're basically doubling the load where the server can't even accomplish the initial load. So the key is to start scaling before you reach the threshold point. If you take a look at this graph, the throughput is manageable till a particular point, and then suddenly the latency increases and the throughput is nowhere to be seen. So in this particular graph, where do you think that we should start scaling? Anyone, like you can raise your hand and just take a guess. Right? You can just shout out the answers.
That is the green line.
Huh?
That is the green line. So latency is increasing. Second line.
Here?
Second line.
So some people say here, some people say here.
Where the actual latency start increasing.
Here. Yeah. Yeah. So whoever said this, give yourselves a pat on the back, because if you scale when you reached here, then like I mentioned, scaling requires some time. till the time you have scaled, the requests that have come in, they won't be able to service. So it is better that you start scaling here, not even this part. Start scaling here, because this is where you see that the latency is increasing. As soon as it starts increasing, you need to take a check as to when, like, should I increase it right now? If the latency is still increasing, scale it then and there, rather than waiting till the third, second, or the first line. Till then, it's too late. So that was for all regular EC2 instances or regular servers. What does Lambda bring in here? Each function execution has an environment, has same finite resources, but each and every event will get one entire Lambda function. So, if you are sending 500 requests, each of those requests will have a separate working environment. That will help your request be fulfilled within that particular time, rather than sending the entire set of 500 requests to a single instance. So each request gets the exact same number of resources. As the work increases, scale concurrent environments. What does that mean? So initially you are getting 100 requests, then you start getting 500 requests. In a traditional environment, you will be sending those 500 requests to the same server, or say you use autoscaling and you spun up another instance, and you will be sending the request to that particular server. But with Lambda, if let's say you have 100 requests and it has gone to 500, so Lambda will scale accordingly, and accordingly the 500 requests will get 500 Lambda functions. So each request will get a new Lambda function. And in the previous example, we saw that the latency after the number of requests increased, it went up, while the throughput did not go according to it. With Lambda, latency and throughput are constant. But this is a very big thing that you should keep in mind, is concurrency limits apply. This is something like that after mutual funds had subject to market risk, please read the documents carefully before. So it's something like that. So you need to know till what extent can your Lambda scale up. The default value is 1000. So 1000 is the concurrent, you can have 1000 concurrent Lambda functions, and that is an increasable limit. But you should know what your limits, like, don't take it personally, we're talking about your accounts limits or your applications limits are. And accordingly, you can either scale up, you can change the limits, or yeah. So these limits are there to keep a check, and these limits are your friends because they help in avoiding unnecessary cost. If you didn't know that your Lambda could scale up to 10,000 and you are doing a cost analysis, it just goes up to 500 and suddenly you face a DDoS attack. And Lambda is scaling up 10,000 and you're facing a sudden surge in cost. So that is where limits also help it. Yeah. So when you say that Lambda is highly scalable, that's great. But there are certain, if your application is only using Lambda, good. But if it's, say, integrated with a third-party application, with a database, you need to check whether your dependencies are also scaling with Lambda. Because it is possible that we can burst to 3000 concurrency, 3000 requests are coming in, but say your DynamoDB currently has a write limit of 100 requests. So in that particular scenario, Lambda scaling up does not make your life easier. On the contrary, it makes your life hard. So you need to understand whether your downstream dependencies can handle the scale of Lambda or any other. So basically, you need to have all your dependencies on a single line. Like I mentioned, downstream services can cause upstream impact. implement retries with exponential backoff. So implementing retries is good, but if you just implement retries in a dumb way, then it doesn't make sense. So if you know that your particular database cannot take in more requests, if you keep retrying it, it doesn't make any sense. So what exponential backoff does is that it will wait for, exponentially keep waiting for more time before sending in new requests. It will wait for 1 second, then 2, then 4, then 8, and then send in the requests. But even better than that is using jitter. I'm not sure if you are able to see this graph, but jitter introduces a randomness factor to it. Exponential is again, it is on a particular scale, right? So by adding jitter, you are adding a section of randomness to the request. So even if it's retrying after every 2 seconds, not all requests will be retried at the same 2-second mark. So why do we have quotas or limits? As a developing, or how many people are developers here? Quite a lot. So whenever you're developing or testing something, have you seen limit exceeded or rate exceeded? You feel frustrated, right? So that is natural, but it, again, consider limits as a friend. It's much cheaper to restrict work at the gateway rather than letting extra work come in and overload your systems, especially for synchronous workloads. Load test your system, someone somewhere. This someone would be the person who had to wake up at 3 a.m. because they got paged and they have to fix their particular infrastructure. So remember that your system will be load tested either by you in controlled environment or by the customers in an uncontrolled environment, and you have business loss. So testing is extremely important, because if you take an example of a fire drill, why do we have fire drills? We have fire drills so that in case of an actual fire, you know what to do. Because suddenly, if you have, say, instructions on how to evacuate during fire, and you see a fire, and suddenly you realize that the doors are small, we can't have so many people run through these doors. You shouldn't be experiencing those particular things during that time of fire. You should be testing it in advance and be ready with it. Stop guessing at capacity. So when you have, say, Netflix doesn't keep sitting in their room in, say, every December or annually once, like, this year we had around 5,000 servers, next year let's just have 6,000. They don't guess. They'll take a look at what all events have happened in the last year. Accordingly, they'll create a threshold limit, they'll create a safety limit, and they'll also have backup scenarios always in place. So in interest of time, I'll just skip this to this particular example, is that when you're using Lambda with Kinesis, the best thing is that it maintains messaging order, and every shard gets, each shard gets one instance. So say the shard has sequential events, say 1, A, B, and C. So Lambda will process it in that particular order itself. But if you have a requirement where you need to, say if you look at the third shard, there are 6 events, right? So if you want those 6 events to be processed very fast, you can do something called parallelization. That is horizontally scaling it, and there will be 2 instead of 1 Lambda processing your shard, but in that particular scenario, you cannot guarantee that all the messages will be processed in the same order. Monitoring. Monitoring is not just about knowing what happened. It's about predicting and preparing for what might happen. So when you should be taking action with either CloudWatch, or if you have any third-party metric system, always use that. But your day-to-day scenario, you should always have alerts on symptoms rather than causes. So if you see that your users are facing latencies, those are symptoms. You should have alarms for that as well rather than, okay, this particular server cannot take any more load. That definitely you should have an alarm for that. But you should also have metrics and alarms to measure the symptoms that your user is facing delays or something like that. And you should also use composite alerts. Not just one alert will give you the entire picture. You need to have composite alerts like the user is facing latency and is facing latency during a particular process that they are doing. That will give you the most clear idea. And also context aware. So if on a particular weekday when you have enough traffic coming in, 10,000 requests might not be surprising to you. But on a weekend when your system, like business is closed, suddenly you get a 10,000 request, you see a 10,000 request metric. That should be surprising, that should alarm you, and that should be concerning. So you should be smartly monitoring your application rather than just monitoring your application. And there's something called X-ray. How many of you have heard of X-ray before? Not a lot of people who use serverless, I guess. So, what X-ray does is that it will trace the entire path of the request. So, say there's a lambda followed by a DynamoDB, followed by a step function, followed by some other service. So, in that particular scenario, the X-ray will take a look at how much time each particular junction took and accordingly give you a metric about that. And this is the last section of today, architectural patterns. So you can reject excess work. We talked about rejecting excess work initially, right? You can do that with API gateway. You can put rate limiting, you can put throttling, you can even do initial input validation and pagination. What does pagination mean? It will break your large responses into smaller ones so that Lambda can handle it, or any other integration can handle it. Enhance durability with asynchronous patterns. So when you send in a request, say to API gateway, and it in turn goes to other. So with an asynchronous request, can someone tell me the difference between 200 and 202 requests? Both are success. But what is the difference between the two?
One is accepted.
Yeah. So 202 means the message has been successfully accepted, but it's not processed completely yet. So in asynchronous, you'll usually see that. So when you, I think we have talked a lot about asynchronous requests today. Yeah. So yeah, this is something that I'd like to bring to your notice, is that disable features with feature flags. What is easier when you put in a new feature and say that new feature is facing a problem? So is it easier to roll it back completely and then deploy a new version of your code, or simply having a kill switch that will just disable that particular feature? Just if you take the example, if you've been shopping on Amazon.com, then sometimes happens that a particular payment method is not working. So in that particular scenario, instead of completely shutting down payments altogether, you just shut off one particular payment method. And app config is one particular service which can be used for that. Okay, so yeah, this is the last for the day. Fail fast with circuit breaker. So in your house, a lot of people have a three-phase electrical architecture, right? So say your fridge overloads and the phase goes off. It is better to have just the kitchen electricity go off rather than the entire electricity of the entire house go off, right? So fail fast with circuit breaker implies the same thing. When you have a particular scenario where you see that a particular feature or something is causing a lot of failure, simply break the circuit, stop the number of requests that are coming in. And you should fail fast so that you can take action on that failure much faster. Something like this. जल्दी खेलो, एरर रिजॉल्व करना है. So yeah, I'll literally the last slide. I know I've been saying last section, last this is literally the last slide. So since serverless is multi-availability zone, why would you want multi-region? Increased availability, you can have a disaster recovery center in a different region, so that if your initial or the primary region fails, then you can always shift traffic to your disaster recovery. To improve global performance, you might have customers all across the globe. So the lowest latency would be from a region that is closer to them. And regulatory requirements, something which you might be aware of, that Europe and China require their information to stay within either EU or within China. So being multi-region is great, but again, it has a complexity task, because you need, whatever you are doing for one region, you need to do for both, and you need to maintain the consistency while having the infrastructure redundancy. Yeah, I think that's it for you. I know it's your weekend. I understand that you could have done a lot more things, just relaxed, but you came here and we're thankful for that. And just give a round of applause for yourself for enduring the things of me. Thank you.
Okay, wow, that was some serious serverless magic. We'll be taking one question from the audience. So, if there's any question. Is there any question?
My session was so amazing that they will not have any.
Okay then, I request sir to please ask any question regarding your session. The winner will get a goodie.
Okay, there was, again, it's, okay,
Okay, before
Yes.
sir asks the question, let me remind. Whoever asked the first the answer, जो सबसे पहले आंसर करेगा और सबसे सही आंसर करेगा, उसको गुडी मिलेगी. Okay, so ऐसा नहीं कि कोई कुछ बोल रहा है तो हम ऐड कर रहे हैं, वैसा नहीं. First one gets the goodie.
Okay, I see. Again, don't hit me for this, but I'm not going to ask a technical question. It's more like a fastest finger first, because I understand that you've been going through a lot of technical stuff the entire day. Tell me the actor's name in that meme. Anyone?
वसूली भाई.
That's the character's name. Okay, which movie is it from? Fastest finger. Was it Gurman 3 first? इतनी देर में मैं भी Okay, I'll ask a technical question. This is getting very easy. So, in a lambda function, what is the maximum number of times that you can retry? You can retry. 1,000 times retry? Two. I said maximum. You can't say 0 to 2 is the maximum. 2 is the maximum. I know you. Who answered? I heard 2 from there first.
So she's been call up.
Okay, whoever answered, please do come on stage. Okay, so it's Simran Vanjani who gave the correct answer.
Check करो.
Okay. To show our gratitude, we now invite our core team members to present a token of appreciation to our speakers. I request Mr. Anmoldeep sir to present the token to Mr. Praveen Kumar Bigdani. Thank you. Now I request Aishwarya Gathe sir to present the token to Mr. Nishant Buddhi. And that brings us to the end of our very first AWS User Group Nagpur event.
A huge, a huge thank you to our incredible speakers, Ms. Ridhima Kapoor, Mr. Praveen Kumar Menghani sir, and Mr. Nishant Buddhi sir, for sharing their knowledge and experiences with us today.
To wrap up this beautiful evening, I now invite our organizers, Ms. Jyoti ma'am and Naresh sir, to give the closing remarks and vote of thanks.
Wait a minute.
Good evening, everyone. I believe you all enjoyed the sessions and the evening here. So, I would like to extend my heartfelt vote of thanks on behalf of entire AWS Nagpur user group community, and special thanks to our speakers who took out their time and share their experience and insights with us. Thank you so much to Praveen and Nishant. Next, I would really want to thank a lot to our volunteers who worked day and night. I know you guys worked literally like 2 team members. Aishwarya and Jyoti are working from 5 o'clock in the morning, and Naresh and Anmol are working complete night. And you all have to cope up with 2 leads. Thank you so much. Your efforts made this event run seamlessly. Next, I would really want to thank a lot to Shekhar. Thank you so much. You have been always supporting to arrange such events, all the technical aspects. Thanks a lot for being the venue partner. And last but not the least, LOC, for giving us a good quick break, cookie and a chai. Thanks a lot. Thank you everyone. Thanks all the audience. You made this event successful. It was so engaging, and thanks. Thank you so much.
Thank you, ma'am. That was wonderful. A big round of applause, especially for all of you present over here, the community that makes this possible. Remember, it's not just about learning, it's about building, sharing, and growing together. AWS gives us the tool, but it's the community that gives us the power. So, keep experimenting, keep innovating, and keep connecting. We have our QR code for the feedback form. We would love to hear the feedback from you and to make the sessions forward more perfect and more better. This link would be open for 24 hours, so I request that you all kindly please scan. If you do it now, it's well and good. And yes, 24 hours and it will be gone.
Also, if you have missed any part of this session या कुछ नहीं समझ में आया है, so we have a YouTube channel on which the complete recording is available. And before you leave, stay back for a group photograph to capture this momentous occasion.
We would be having our photographs over here. So I request whoever is sitting at the back, kindly please fill these spots, and we will be coming down to the stage and the photograph would be taken. It would be amazing. Come on guys.